Okay, let's get started. Thank you for joining. Thanks for coming to my talk. It's great to be here for me for the first time at GeeCON here in Poland. Last year I was at GeeCON in Prague. It was so amazing that I wanted to come back, and yeah, thanks for having me. This talk is about high-performance Java Cloud native apps, and I like to talk a little bit about how you can build the fastest applications in Java. So we all know data are exploding. So since 2026, data should be become and explode 10x. And data are everywhere, and we all have this IoT stuff, machine learning, AI. And what is interesting is, couldn't believe that actually, 75% of all databases are already run in the cloud. And for IT decision makers, this is really painful because most of them, more than 90%, say that cloud storage costs are really exploding, and this is a really big pain point for them. And more than 50% of all decision makers, they say that cloud storage costs is really a big pain point for them. So the question is, can we improve this with Java? And I have been working for now almost 20 years with my team on this topic. So for us was always a dream to simplify database development and provide something that is more simple to use and faster than ever before. So this was our big goal. First of all, something about myself. My name is Markus. I'm CEO and co-founder of MicroStream. As a team, we are a contributor to various open source projects. We started with RapidClipse, which is a visual Java development environment, a little bit similar to Visual Basic, but for Java. This was our initial project. We built this based on Eclipse, so it's open source and free to use. The entire framework is open source from the beginning. We're also contributing to Project Helidon and also to Micronaut. I'm working as an editor-in-chief for the German Java Pro magazine and run the GeeCON conference. So together with colleagues like Richard Fichtner from XDev. And so this is a little bit about my background, building Java development tools for more than 15 years now. This is the team behind the EclipseStore project, which is now our main project. This is what we are working on daily. So we are passionate Java developers, and these guys are our mentors behind the EclipseStore project. So RapidClipse is in version 11 currently. So as I mentioned, you can download this, check it out. Accelerate UI development. As I mentioned, the MicroStream project, which is now becoming the EclipseStore project, is part of Helidon. We are contributing to Micronaut. And we are super happy to announce at GeeCON for the very first time that MicroStream now is divided into two projects. So MicroStream Serializer becomes now Eclipse Serializer. It's scheduled for May, so hopefully we can launch it in May, and the MicroStream persistence becomes now EclipseStore. And EclipseStore will become a new standard. So we will start working on the new standard, similar to the JPA standard, already starting this year. So let's talk a little bit about the background. So everything started with virtual machines, actually. So before we had the virtual machines, so we were used to use physical servers, buying big machines, running big applications on big machines, very heavy weight, but this was common. Then the first revolution actually was the virtual machines. So now we were able to share our resources with virtual machines. The next step was containers. Now we were able even to ship smaller functions, not only the big applications in total, also the small features in a container, in a separate container, where we were able to deploy and to run it separated from each other. So this was really revolutionary. The cloud has changed everything. And actually, what does this mean, cloud? So, of course, we have the same data centers than we had before. But with the cloud, we were also now able to share the resources very easily just by coding. So creating infrastructure by code, then scaling horizontally, scaling small applications in the cloud, scaling microservices in the cloud. So this changed everything. Okay, what does this mean, microservices actually? So before we were used to build monolithic applications, and the complete Java stack was built for monolithic applications. Now with microservices, everything changes. We are now cutting a monolithic application into numbers of microservices. So mostly the features we were able to create as modules before become now microservices. So just by cutting the monolith. It sounds simple. So we cut it into numbers of single services, and each single service should run in its own container, run independently from each other on a container platform that will manage our services, hopefully automatically behind the scenes. So this is the basic concept. But with Java and microservices, there were some challenges. And by the way, who of you develops microservices already? Nice, that's good. Who of you thinks that you actually develop not microservices, but kind of like macroservices? Okay, so more like modules, but separated into container running independently. Very interesting. There are perhaps some challenges with Java, and when microservices and serverless computing came up, then the question really was, is Java still suited for tiny services, or should we move over to Node.js? Who of you uses Node.js? No one? Okay, that's good. All right, so with microservices, there are some requirements, actually, some rules. So each microservice should be tiny, should be responsible for only one specific task, should be small, should run its own container. And when the microservice crashes, should be able to start initially, immediately in milliseconds. So fast startup time is very important. And of course, to achieve this, a microservice should have a low memory consumption. And in terms of storing data, a microservice should have its own database. Who of you has performance issues in terms of startup times of your services. Okay. All the other guys have no. Okay. Services are fast enough. Interesting. Who of you uses GraalVM native images? Only one. Come on. Okay, okay. In production? Interesting. This information is for me personally. The challenges with Java actually was we had these application servers. So we were used to build big applications running on big machines, and as an environment, we used an application server that was also built for running on big machines. So startup time was not important. So start the application once, runs for 3 years or even longer. And also memory consumption was not an issue or startup time. What's about the JVM? It's the same with the JVM. So JVM also was built for monolithic applications that start once and run for perhaps years without stopping the application, which means our JIT compiler has a warm-up time, but this was not that important. As soon the JIT compiler is hot, the JVM is super fast, and so incredible fast. We have really now fast Java applications. This changes with microservices, because microservice, and especially when you use serverless functions, then it should be able to start quickly in milliseconds. This will not fit with the JIT compiler, which has a warm-up time, and so has a slow startup time. What's about persistence? Each microservice should have its own persistence. What does this actually mean? Does this mean you will have a database server for each microservice? This would be challenging. With serverless computing, we have stateless microservices, but with database servers, we have these monolithic concepts as well. So running microservices with a monolithic database server with stateful database connections, this is also tricky. And each microservice should be responsible for a specific task, and so which means perhaps one microservice is responsible for IoT data, storing machine data. So which data structure would be great for that use case? A graph? Perhaps not. Time series database. What about complex data with lots of relations? Would you use a time series database for that? Obviously no. Perhaps a graph database would be a great idea. So, which means you have various microservices, various databases to handle in your microservice architecture and application. This can be challenging. So the database vendors have a great idea. Now we build a multi-model database. Check it out. Then we have also challenges with the container platform itself. So running Kubernetes, managed or not managed, running serverless applications. So it depends on the use case, but there are also challenges. So now with Java, we have solved all of these problems. This is good news. So we don't have to think about moving to Node.js or Python and for writing microservices. So I hope this is a good information for today. So it was solved by transforming the old application servers into small, tiny micro runtimes. So only a small container for running only one microservice. This was game changer number one. So when I talk about this, because this always confused me, I didn't understand it. So here is a big picture. Here you can see both worlds, Spring and Java Enterprise, which is now called Jakarta EE. And we have all of these application servers, IBM WebSphere, WebLogic, JBoss, Wildfly, Payara, and so on. And now it changed to micro runtimes, and so we have now two different microservice frameworks, the microprofile frameworks, and we have the frameworks that do not follow the microprofile standard. And microprofile, similar to Jakarta EE, is now a new standard for how to build a microservice framework. And here we have various providers like Quarkus, Open Liberty, Payara Micro, or Helidon MP. Helidon is, by the way, very special because it provides you two frameworks in one. It's the only framework that also provides a smaller framework, Helidon SE, and then we have all the other micro frameworks like Micronaut. And of course, Spring with Spring Boot. And who of you uses Spring, by the way, or Spring Boot? Okay, interesting. What's about JVM? This was really a problem because we have this warm-up time of the JVM. How should we solve that? Then Oracle came up with GraalVM, and GraalVM is a very interesting project. When I heard it for the first time, I had no idea what actually it is. So it enables polyglot programming, which is super interesting. Who of you uses polyglot programming with GraalVM? No one. So you're not interested in Node.js. Okay. Perhaps more interesting is the feature of creating native images. And Oracle says the startup time will be 50x faster with the GraalVM native image. So that's great. And also the memory footprint will be much smaller. But using GraalVM has also challenges. So ahead of time compilation, it will increase your build times, of course. Testing and debugging a native image is really tricky. And there are other challenges, reflections, and it's not as fast as the JIT compiler. So as soon as you run a common JVM with the JIT compiler, a hot JIT compiler will be faster than a native image. And you can't change anything through runtime. So perhaps this is the reason why not that much people in the room use GraalVM native images, right? Who of you, again, needs a faster startup time for your services? Very important question for me. Okay. Then I can skip the next slide. No, I do not skip it, because it's super important, because with OpenJDK project Crack, you will be able to use and keep your traditional JVM. And it can store the state of your system, which means it can store the optimization of the JIT compiler. And when you shut it down and start it again, it can load the system state and the JIT optimization state and restore it. And this accelerates the startup time of your JVM tremendously. So there are also great talks at GeeCON about this topic in more detail. So just ask Gerrit from Azul. Gerrit, are you here? Ha, yeah, ask Gerrit about this amazing feature. And it's not for the Oracle guys. You don't need GraalVM native image anymore. Serverless computing. We also have some challenges with serverless computing because it sounds great, actually. So the concept is that you just focus on writing your application code and don't focus on anything else. Don't focus on the infrastructure. You don't have to care for how your environment should scale in, scale out. You don't have to care for that. And you only pay for what you really run and how long you really run your services. For instance, AWS Lambda is a serverless computing platform. It's event-driven, which means it triggers an event, starts a serverless function, and executes your function. And after executing your function, it shuts down and goes sleeping again. And you don't have to pay anything. Just pay for what you use. And of course, it supports Java. Here we also can see it supports other programming languages. But with Java, we are more effective because of the great JVM, JIT compiler. We are much faster. And now we have also solved the startup time and the warm-up time of the JVM. So that's great. And so here we can see that we now replace just the environment for our services, for our microservices. Wrong slide, doesn't work. So actually, yeah, it's hard to see that. So it should now remove my container platform. So just deploy your microservices to serverless functions to a serverless platform. All right. And in comparison with the managed Kubernetes, for instance, like EKS, it scales automatically. It scales horizontally and also vertically, like EKS also. And you don't have to manage the infrastructure and the resources. So this is the main benefit. And of course, the costs. And the interesting thing is that you don't have only to run, or you don't, or you needn't only run small functions. You also can run bigger applications, which means kind of like fat serverless functions in a serverless function. So it really can make sense because you can build a serverless function that is available all the time. You can ping it, then that is not shutting down. So it depends on the use case, but this can also make sense to just migrate your existing code and execute it in a serverless function. So it depends on the use case, but this is also possible, and you can consider using serverless functions for that use cases. From traditional Java persistence to micro persistence. So what's about persistence? So I mentioned already, each microservice actually should have its own database. It feels heavy-wide, so using various different database systems for different use cases. So the question is, can we do this better? And we also have challenges with traditional persistence in general. It's because the talk is about high-performance applications. So we want to build really fast services or applications. What's wrong, or what's the challenge with traditional persistence? With Java, everything is great. Everything is object-oriented. It's fast when we execute code in memory. As soon as we want to store data, we leave the Java way. It's because databases work fundamentally different from Java, and I mean all databases, because they introduce completely different data structure or formats. With relational databases, of course, we have tables and columns. And storing objects or complex object graphs in a relational model, from a technical perspective, this is actually not possible. We have various impedance mismatches here, and these concepts do not fit together. This is the reason why you have to adapt your object model to the database model and have to develop your application around the database, just for storing some data. With the modern NoSQL databases, something changes. I think the biggest challenge here is that they introduce completely new data structure or formats, like document stores using JSON or XML, or graphs. Who uses graph database? No one. Not that interesting. Okay. The problem here is they are all incompatible with the Java object model. You need a kind of like mapping or data conversion here as well. And you also have to adapt your classes to the database models. To solve this problem with relational databases, we have these object relational mapping frameworks like Hibernate. And we have this object relational mapping or SQL code generation through every single read and write. And this is the reason why database applications are very often slow. Impedance mismatch. To accelerate database applications, we are used to add a cache. Then everything is fine, so it's a little bit faster, but not that fast as we would expect. Because when I read data from a cache, I would expect I read from data from memory, it takes microseconds. If you measure how fast the Hibernate cache is, then we will see they're not microseconds. So the problem here is that the objects are serialized and have to be deserialized when you store it in the cache. So it's faster, but not incredibly fast. And we have some challenges here as well. So if we build distributed applications, so we run our service or our application with multiple nodes, we change some data in one node, then this node will be in sync with the database. The problem is all the other the other instances are not in sync with the database. This might be a problem, but of course we can solve this problem. Just put the cache in between the application nodes and the database. This would be a single point of failure. We should avoid this. This is the reason why we use a distributed cache. And we see we have now two clusters running. If the load goes up on the database, we are used to share the load through multiple database nodes, and so we have a third cluster here. So our complexity of the system increases more and more. And initially, just for storing some data, right? Question is, can we do this more elegant, better, faster? We believe, yes, we can improve this. And with plain and core Java. So with Java, we have everything actually we need. We have a super fast JVM. Executing or processing data in memory with pure JVM power will be incredibly fast. We talk about microseconds. What's about data structure? Can we handle all of these different data structures in Java? Yes, of course. With the Java object model, we can really use everything. We can store a simple list for kind of like time series data in a memory very easily. But we also can create a complex structure, like a complex graph with circular references, with millions of relations between the object nodes. So we have the perfect multimodal data structure already. What's about searching? With Java Streams API, we are now able to search and filter Java object graphs in memory in microseconds. Even if you have terabyte memory and data in memory and a complex object graph structure, it will be searched and filtered in microseconds, up to 1000x faster than a comparable JPA query. Here are some numbers. It shows that when we have access to memory, it mostly means it's executed in microseconds. When we access a disk drive, mostly it takes milliseconds. And the factor is 1000x. So it's really possible to accelerate database queries with pure Java up to 1000x. It's incredible. With this performance, you can build completely revolutionary new features and products. Or you save lots of energy, CPU power, and costs in the cloud, especially in the cloud, with just Java performance. The big question is, why don't we use it? So it's because we need some persistence for our objects, and Java does not provide anything for persisting your objects. And the databases, they were already existing when Java came up. So it was obvious that we store data in a relational database. What's about the costs? This is super interesting because databases in the cloud are expensive. Why? Let's assume we need a PostgreSQL as a service, 250 gigabyte, okay? One node, 4 CPU, 16 gigabyte memory costs you around $8,000 per year. But it's just one node. If you need replication, high availability, you want to share the load through multiple nodes, the price will skyrocketing. So with only 6 nodes, we'll pay $50,000 per year for this service. If you use a blob store like AWS S3 or Microsoft Azure Cloud blob store, it costs you around $70 per year. That's crazy. So it's more than 90% cheaper to use a blob store. So why not combining the performance of Java with the cloud blob storages? This functional principle is known since decades, and the idea is not new, but now we have a solution for that. So the functional principle is called system prevalence. It's a really simple concept. Just keep your objects in memory. Execute data processing in memory, execute everything in memory, search and filter in memory. This will be fast, and the system complexity will be low and super easy to develop. And just serialize your objects to disk. Cool. Sounds great. But should we really do that? The problem with this concept was creating a snapshot, which means storing your entire database to disk on each change is not a good idea. So this is perhaps the reason why this functional principle was not that popular so far. But with EclipseStore, we have now solved this problem, and because we create just micro snapshots of the changes in memory. And this is how EclipseStore works, and now provides you a high performance persistence, especially for the cloud. So it's a Java native micro persistence layer. It's similar to Hibernate, but without any mappings, no object relation mappings anymore. It allows you to store any object, any kind of object graph, any size, any complexity, and also individual subgraphs persistently on disk. And it stores only the changes on the object graph. And vice versa, it allows you to just load object references by calling a get method, and then the engine loads the subgraph into the memory and merges the subgraph directly into your object graph. So you don't have to deal with object copies anymore. This is, in a nutshell, what EclipseStore does. It's a tiny open source library. You can download it via Maven, and it will be available on GitHub soon under this EclipseStore.io website. The functional principle, as I mentioned, is really simple. What we did is just have a look inside a database. Then we can see we have in a database server, we have also a machine, we have storage, we have a database management system. We need some memory in our machine because the database server has to search data. So the more memory you use, the faster the database will be. But as I mentioned, we do everything with Java. So which means we now replace object relational mapping or a data conversion we need for a NoSQL database. We replace this with EclipseStore, and we use the object graph in memory as an in-memory database. Query and filtering with Java streams. It's in memory already, which means we don't need a cache anymore. So we can skip our local cache. So the complexity can be reduced. Because everything is already memory, we don't need memory on a database server side. We can skip it also. And the database management system is, or the task of a database management system are mostly covered by the business logic anyway. So because we can do it in Java better. So the only thing we need actually is persistence, is storage. And we store the data in a binary format persistently on disk. And for that, we use the Eclipse serializer, which is also a new Eclipse project. And with this functional principle, we are now able to store any kind of objects into a blob store, like S3. But we also have connectors to traditional databases. This might be a little bit confusing because we have connectors to traditional databases like MySQL, but we don't, be careful, we don't use the relational model anymore. Because MySQL is also able to store binaries, right? So this is the reason why we can use it, but it's not mandatory. EclipseStore runs wherever Java runs. The only requirement is Java version 8. About the performance, this is really incredible. So it's because we search object graph in memory. We can expect that execution time is very fast. So here is a small performance demo. Here are two applications running in parallel. We have a bookstore demo, 250 gigabyte PostgreSQL database, and one application is built with Hibernate and cache. The other application is built with EclipseStore. And here we can see the query code that is executed, and every query is executed sometimes only 160, 70 times faster, sometimes 10 times faster, mostly more than 1,000 times faster than the comparable JPA query. This is only, by the way, this is not the performance of EclipseStore, this is the JVM performance. So, and here we use hotspot. So, if you use a faster JVM, so we have tests with Azure, for instance, much faster. So change the JVM and your database application will also be much faster. It also depends on the Java version. If you use a later Java version, it will be much faster. And if you have improvements in the JVM in Java, this is great, because then your database application also will be improved and will be much faster. With now virtual threads coming up in the next Java version, hopefully, Java 20, this will change everything, because this will execute your application much or way faster than before. And you get this all for free. That's great. So this is why we believe with Java we can do it better. And good news for you guys as developers, you don't have to learn anything, new stuff, because you don't have to learn database stuff anymore. So it's just core Java. So, and requirements to your classes, nothing. Just pochos. No, you don't have to care for any interfaces to implement. You don't have to use to implement serializable. You can use all Java types. There are no annotations, just pochos. And so this simplifies database programming tremendously. Right. What's about distributed apps with EclipseStore? Again, this is our traditional application and architecture we see in many use cases. And by the way, sometimes there is additional Elasticsearch cluster, right? Just for searching. So, and by the way, with Java streams and Lucene in combination, we don't need a search cluster anymore. So we reduce, or we replace the traditional application cluster nodes with EclipseStore nodes, because they are much more powerful, much faster. We don't need the same amount of machines anymore. So because of the performance, incredible performance, we save nodes and machine and costs in the cloud. Now, the object graphs in these JVM nodes are replicated, which means we keep the data in memory. They are already memory, which means we don't need a distributed cache anymore. We store it in AWS S3, and Amazon, or if you use Microsoft Azure Cloud, it cares for distributing your data. It provides you even data center replication, so you don't need a database cluster anymore. We can skip the database cluster, so we save a lot of machines. Just pay $70 per year, that's it. As I mentioned, we replicate now the object graph through hundreds or thousands of JVMs. We don't need the distributed cache anymore. So the architecture gets more and more simple. This is what you get out when you use EclipseStore. And by the way, the complete project is open source under EPL. Now, what we can do is now replicate our application or microservice nodes. By the way, you can use it for monolithic applications and for microservices as well. So it can be big application cluster or a microservice cluster to scale in and scale out your apps. But you also can put the EclipseStore cluster in between your application nodes or microservices. Then they can be stateless and just query the EclipseStore cluster just by REST calls. You also can use GraphQL for that to query the EclipseStore cluster. The queries have to be implemented with Java, of course, or with any other JVM languages. You can use Kotlin for that. And you can this is now a good news also for the Node.js guys. You can also run Node.js web services and query a EclipseStore cluster, but not interesting for the audience here today, of course. So this is the functional principle in a nutshell. The code is very simple. For instance, you can see how a class should look like. Pocho, that's it. So no annotations required, no superclass, no interfaces to implement, just Pochos. And build your object graph freely. The only thing we need is an instance of our object graph. It's just a root object, and then you can add any Java types to the root instance. To persist objects, just call a store method. That's it. And a MicroStream will store just the changes. Just the delta is persisted on disk. And each store is transaction safe. It's an all or nothing operation. Very simple to use. We also provide, of course, lazy loading, which means you can load all data in memory. If you have enough memory, you can do that, of course. The more memory you have, the faster your application will be. But it's not mandatory. You can also use micro machines, serverless functions, and you have gigabytes of data in the storage because you have lazy loading. Just load the data that is really needed by using lazy loading. You don't have to care for memory management. It's everything covered by the JVM. So don't care about that. You can, of course, can manage your lazy references. You can clear lazy references if required, or you want to do that. But actually, you don't have to care for. So everything is done by the JVM behind the scenes. Searching, filtering, just Java Streams API. You also can use GraphQL for that. And allowing third-party applications access to your applications, you also can use GraphQL for that. So, what's about time? There are also some rules and challenges with MicroStream or EclipseStore. Two things. Here on the left, you can see the traditional database paradigm. We have a Java application, we have a database server. And it's different with the EclipseStore paradigm. Because now your database is in memory. This is your single source of truth. That's a big difference. So you search and filter the same JVM instance as your business logic runs. That's very important. So there is no more database server you have to query. You don't send a select to a database server anymore. There are no more selects. When you start the application, then EclipseStore loads the object graph into the memory, but only the object IDs. Then you just have to call get methods, and EclipseStore will load the object reference into the memory. So it's fully object-oriented. And really smooth, feels great. And also you have with Streams API a type-safe query language, so no more SQL strings. So that's important to mention. And you can also create your own indexes and persist your indexes. You can use Lucene or anything else that's available in the Java ecosystem. With the upcoming version, we will provide you pageable collections for searching and filtering huge amount of or huge collections. So I mentioned already, if you have a lot of memory, you can also load the entire database into the memory. That's possible, and it's recommended if you want to do that. For microservices, this might be not a good case because you need fast startup time. If you have not enough memory, have big storage size, no problem. This works also with micro machines because you have lazy loading. So conclusion with EclipseStore, in combination with the JVM, with the Java object model, with Java itself, everything is simple. Storing data, managing data is way simpler than ever before. Get a high performance by using Streams API, microsecond query time instead of milliseconds, means 1000x faster. And in terms of saving costs, it's more than 99% cheaper to use a cloud blob store in comparison to a database as a service. And we didn't talk about database license fees. So you will save the database license fees on top of that. All right, challenges and with EclipseStore, there are challenges. You have to care for concurrency, and if you're a DBA, you're out. It's built for Java developers. It should feel like a function of Java. It should feel not like a database. It should feel like a core Java function to store data. This was the initial idea and the use case for EclipseStore. It will be available soon, so now you can find the project as under EPL at microstream.1, documentation, examples, videos, and in some weeks we will find everything on EclipseStore.io. It also becomes a new standard similar to the JPA standard, and then you can use this for free. And last but not least, I have now a small gift for you guys. Of course, you can now enroll for free trainings if EclipseStore is interesting for you. Just enroll free for online courses. We provide this under Java Pro IO training. And join our raffle at our booth, because then you can also enroll for all other online courses for Quarkus, Payara Micro, Spring Boot, and we provide also courses for Micronaut. Yeah, just check it out, give us feedback. Thanks for joining. If you have any questions, you can find us on our booth. Thank you so much.